This is Euclid Book 10, proposition number 98, and yes, this is the same diagram. The square on a first apotome of a medial straight line applied to a rational straight line produces as its breadth a second apotome. Let AB be a first apotome. That's this one right here. And it's going to be the first apotome of a medial straight line, and CD a rational straight line. So this is going to be a rational straight line. And to CD, let there be applied CE, so we're going to apply this area right here to CD, equal to the square on AB. Okay? Well, we already know how we got AB because I told you that in the last video. So now we're going to say that this area is equal to this area, which makes CF the breadth. I say that CF is the second apotome. For let BG be the annex to AB. This is going to be annexed to this. Therefore, AG and GB are medial straight lines commensurable in square only, which contain a rational rectangle. This is by Euclid Book 10, proposition number 74. Alright. So, this line here and this line here are medial straight lines. They are only commensurable in square. And they contain a rational rectangle. So if you took this line and you made them into a rectangle, it would contain a rational rectangle. To CD, we're going to apply something else. Let there be applied CH. That's this, this, and this. Equal to the square on AG. So all three of these areas combined are going to be equal to that. Producing CK as the breadth. That's the breadth. And KL. Alright, now we got KL, which is this area right here, equal to the square on GB. That's this. This area is equal to that. Producing KM as the breadth. There it is. Therefore, the whole CL, okay, that's this, 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 and this, is equal to the squares on AG and GB. So if you add these two squares together, you get all this area. Therefore, CL is also medial. This whole area right across here, everything you see is medial. This is by Euclid Book 10, proposition number 15, and Euclid Book 10, proposition number 23, porism. And it is applied to the rational straight line CD, producing CM as the breadth. So now CM is a breadth. Therefore, CM is a rational. Okay, CM is going to be rational. It's also going to be incommensurable with CD. That's by Euclid Book 10, proposition number 22. Now then, since CL is equal to the squares on AG and GB, since this is equal to these two combined, and in these the square on AB is equal to CE, this is equal to this, therefore the remainder, twice the rectangle AGGB, that's this rectangle, the area inside of here is going to be multiplied by 2, and it's going to be equal to this, this, and this. This is by Euclid Book 2, proposition number 7. So twice the rectangle AG and GB is rational. So if you take this area, you multiply by 2, you get a rational area. Therefore, the area inside of all three of these combined all this, it's going to be rational. And it has been applied to the rational straight line EF. It's been applied to this. Producing FM as the breadth. Therefore, FM is also rational. This is rational, and it's commensurable with CD. Like this. That's by Euclid Book 10, proposition number 20. Now, since the sum of the squares on AG and GB, you add these two together, that is CL, which is this whole area right across here. Because that's medial, while twice the rectangle AGGB, so we're going to take this area, we're going to multiply by 2. That is FL, which is this, this, and this. Because you take this area, you multiply it by 2, you get all this. Because this area is also rational, therefore, CL is incommensurable with FL. All of this area here is going to be incommensurable with this area right across here. But as CL is to FL, as all of this is to all of this, so is CM to FM. so is this line to this line. That's by Euclid Book 6, proposition number 1. Therefore, CM is incommensurable in length with FM. Okay. Therefore, this is incommensurable with this. This is by Euclid Book 10, proposition number 11. And both are rational. Therefore, CM and FM are rational straight lines commensurable in square only. Therefore, CF is an apotome. This is an apotome. This is by Euclid Book 10, proposition number 73. I say next that it is also a second apotome. For let FM be bisected at N. We're going to bisect this line right here. And let NO be drawn through N parallel to CD. I'm going to draw this. It's going to be parallel. Therefore, each of the rectangles, FO and NL, okay, that FO is this rectangle right here, and NL is this plus this, they are both equal to the rectangle AGGB. So this is equal to this, and these two combined is equal to that. Now, since the rectangle AGGB is the mean proportional between the squares on AG and GB, so this is the mean proportional between this and this, and the square on AG is equal to CH. Okay? This is equal to this, this, and this. And the rectangle AG and GB, that's this, is going to be equal to NL, which is this and this. And the square on BG is equal to this little area right here. Therefore, NL, what is NL? That's this and this together, is a mean proportional between CH, which is this, this, and this, and KL, which is this little area right here. Therefore, as CH is to NL, as CH, which is this, this, and this, is to NL, which is this and this, so is NL to KL. So as this and this is to just this by itself. But as CH is to NL, as this, this, and this is to this and this, so is CK to NM. Alright? So is this line CK to this line NM. And as NL is to KL, as this and this is to that, so is NM to MK. So as this is to that. This is by Euclid Book 6, proposition number 1. Therefore, as CK is to NM, as this, this, and this is to this and this, so is NM to KM. So as this line is to this line. This is by Euclid Book 5, proposition number 11. Therefore, the rectangle CKKM, that's this rectangle right here, is equal to the square on NM, which is this, by Euclid Book 6, proposition number 17, that is, to the fourth part of the square on FM. This is the fourth part of the square of this. Since then, CM and MF, since CM and MF are two unequal straight lines, and the rectangle CKKM, right here, equal to the fourth part of the square on FM, and deficient by a square figure has been applied to the greater CM. Okay, so we've applied this to this, and divides it into commensurable parts. Therefore, the square on CM, which is this right here, is greater than the square on MF, which is this one here, by the square on a straight line commensurable with CM, which is Euclid Book 10, proposition number 17, and the annex FM, this line right across here, is commensurable in length with the rational straight line CD set out. This is commensurable with this. Therefore, CF is a second apotome. This right here is the second apotome. And this is by Euclid Book 10, third set of definitions, number 2. And that concludes Euclid Book 10, proposition number 98. I will tell you more in the next video, so stay tuned.